Okay, in this question, table gives some chemical properties of transition element and their compound, and group 1 element and their compound. Chemical property: ability to act as a catalyst, transition, yes. Group 1, no. Exists as a colored compound, yes. Group 1, no. What is meant by a term catalyst? So it's of 2 marks. Definition of a catalyst: the substance which alter the rate of the reaction and without chemically used up or consumed. So if a substance, so without chemically change, if a substance is changing the or altering the rate of the reaction, we call that substance as a catalyst. Give one other chemical property shown by transition element which is not shown by group 1. Another chemical property. Now already they mention physical property. Melting point is a physical property, not the chemical. Forming a colored compound, they already mentioned, because in the question they ask, give one other chemical property shown by transition which is not shown by. So already 2 of them they already showed. So they have variable oxidation states. Variable oxidation state or variable valency means, like sometimes they tend to lose 2 electrons, 3 electrons, maximum it can lose 7. That's why like a manganese, potassium manganate, it is +7. So variable oxidation state or shows variable valencies. Give 2 physical properties shown by transition element which are not shown by group 1. Now this is a physical property. So for
Colored compound.
physical property, colored compound, actually the formation of a colored compound is by chemical reaction. A physical property.
Stronger.
You can mention hard, strong here,
Hard.
because high melting or boiling point, harder or hard, stronger, denser or high density. So these are the terms you can use for physical. So you have to, according to the question, you have to write the property. If they ask physical, write a physical property. Transition metals are harder than group 1 metals. Group 1 are soft metals. Even by a knife, you can cut these metals. Compared to group 1, the transition metals are harder, high melting point, high density. Okay, in the next question, the energy level diagram shows the energy profile for a reaction between a zinc plus dilute sulfuric acid. Complete the diagram by adding a formula for product. Metal react with acid, zinc plus sulfuric acid. What will be the product? Include the state symbols as well. So zinc sulfate, what will be the state? Most sulfates are soluble except calcium, barium, and lead. So zinc sulfate will be aqueous, and metal plus acid gives salt and hydrogen. So hydrogen is there, which is a gas. Draw an arrow on the diagram to represent the activation energy. Activation energy is always from reactant to the start position where the reaction starts. So this arrow is representing activation energy. Is the reaction endothermic or exothermic? Which type of reaction is this? It is exothermic. Exothermic reactions, reactant have, all salts are not aqueous. You have to go through that table which we discussed in the beginning of chapter 2 that all nitrates are soluble, most sulfates are soluble except barium, calcium, and lead. Most chlorides are also soluble except silver, mercury, and lead. And most carbonates are insoluble except potassium, sodium, and ammonium carbonate. So this is an exothermic reaction. And why it is exothermic reaction? Because the reactant have more energy and product is having less energy or energy released to the surrounding. Yeah, or it give out more energy than energy taken in. In the next reaction between zinc and dilute sulfuric acid can be catalyzed by addition of aqueous copper 2 sulfate. So copper 2 sulfate can catalyze this reaction. On the diagram, add on the diagram, add the energy profile for the catalyzed reaction. So for what catalyst will do, catalyst will lower this activation energy or make the reaction occur at lower activation energy. So when you complete this, just complete to show there will be activation energy but lower energy profile means the diagram which is representing the change in energy for the reaction. That is called energy profile. So this one is without catalyst, activation energy is higher. The reactant need more energy to start up the reaction, but with catalyst, the reaction can occur with a small amount of energy intake. A student electrolysis The student electrolyzes aqueous copper to sulfate using the apparatus shown. Oxygen gas is formed at positive electrode or anode. Write an ionic equation for reaction at negative electrode, include a state symbol. So basically what happened, because it is aqueous copper sulfate, so when it is aqueous copper sulfate, it means it contains copper ion. I will write it beside it. So it contains copper ion, it contains sulfate ion, it contains hydrogen ion, and it contains hydroxide ion. For positive ion, we check the reactivity. Copper is less reactive, so move towards cathode. For negative ion, we will check the amount, but sulfate, nitrates, and carbonate will never move, so hydroxide will move. So we have to write an ionic equation for negative electrode. Negative electrode or cathode, copper will move. So when copper will move, it will take 2 electron and change to copper atom. And this is inert using inert electrodes, because whenever like carbon or platinum electrodes are there, these are the ions which are present in the solution. So copper ions which are present in the solution, hydrogen ions are also present. For positive ion, we check the reactivity, because copper ion is less reactive, so they will move towards cathode. When copper ion means they are aqueous, they take electron, 2 electron, change to copper atom, and that will be solid. Yeah, that's right. Copper, which is a +2 ion, aqueous, take 2 electron and change into copper atom. Describe what the student observed at negative electrode. At negative, because copper ion change to copper atom, and copper atom will stick to the cathode. So what he will observe? Instead of mentioning a metal, increase in size of cathode you can mention, or mass of cathode, or you can mention a solid form instead of mentioning a shiny metal. Because observation, we don't conclude that a brown solid, you can mention that as well, because copper is brown or pink. So a solid is formed at cathode, or a size of cathode will increase, or um, in an observation, because you are not measuring a mass, so mass, the mass will increase, but it is not like you can observe that in mass is increasing. It is not on the balance. Give two other observations which student make during the electrolysis. What are the other two observations which the student will make during this electrolysis? The blue color, in this question, we don't have any catalyst. A blue color become dimmer and bubbles. So the things, a bubbles are a fizz, and the solution become, why the solution is become paler or lighter? Because the amount of copper in the electrolyte is not used up. You cannot say electrolyte used up, because what happened, the color of this electrolyte is due to copper. It contains a copper ion, it contains sulfate ion, it contains hydrogen ion, and it contains hydroxide ion. For aqueous electrolyte, we don't mention electrolyte used up. For molten electrolytes, we mention electrolyte used up. So copper ions, the amount, because as they are moving towards the negative electrode, so amount of copper ion in the solution is decreasing. That's why the solution will become paler or lighter in color. And then second thing, because hydroxide, whenever hydroxide ion, four hydroxide ions will move there, they will lose 4 electron, give oxygen plus 2 water molecule. So oxygen gas is there. The oxygen gas is responsible for the bubbles. So bubbles at anode. And the solution will turn paler. How we know the color of the metal? Basically, you are learning only most of the color, compound color, which are having copper, iron. Like if, as we discussed in the salt and identification, so the color of the precipitate, but not all the compounds of a copper are blue in color. Like copper carbonate is green in color. There is one table I'll share today with you, and you can go through that table and learn the color of each compound. Next is, what difference would the student observe at a positive electrode if aqueous copper 2 sulfate is replaced by concentrated aqueous copper 2 chloride? So what difference we'll observe? Instead of copper sulfate, we have copper 2 chloride concentrated. Because when chlorine will move, and what is the appearance of the chlorine? Chlorine is yellowish green gas. So a yellowish green gas is given off at anode, because oxygen is colorless, carbon dioxide is colorless, but chlorine is yellowish green. Or green gas acceptable, you can mention that. Instead of colorless gas or bubbles, you will see a colored gases there. Okay, this question is related to organic chemistry. The table shows the structure of 4 hydrocarbons. So there are 4 hydrocarbons. Why are compound P, Q, R, and S known as hydrocarbon? What is the reason why we call them as hydrocarbon? So because they contain carbon and hydrogen only, there is no other element. That's why we are calling them as compounds contain carbon and hydrogen only. The term only you will find is giving you a mark as well. See, they contain carbon and hydrogen atoms, that's 1 mark. And then mentioning only is having a mark. Compound P is saturated. What is meant by the term saturated? For organic compounds, saturated does not mean soluble, or unsaturated does not mean insoluble. Saturated hydrocarbon means they contain single bond. Within the structure, they contain a single bond. So when single bond is there within the structure, we call them as saturated hydrocarbon. So you can mention all carbon-carbon bonds are single, or throughout the structure, there is a single bond present throughout the structure. Compound P undergoes substitution reaction with chlorine. Compound P undergoes substitution reaction. What is compound P? Compound P is what is the name of this compound P? Which contain two car, it is ethane. So if I write a molecular formula of ethane, it is C2 it is C2 and H6. If it react with chlorine, substitution reaction means when one atom enter, the other atom, here it contain a single bond. There is no double bond. In a substitution, what happened? One chlorine atom will enter and one hydrogen atom will be removed. We call that substitution. So product will be C2H5Cl plus HCl. That will be the product. Because the substitution occur in alkanes and addition occur in, what is meant by the term substitution reaction? So definition of substitution, when one atom or group of atom replace the other, we call that as substitution reaction. So when one atom or group of atom is replaced by another, we call that as substitution. The reason why I show you the marking scheme, so that you understand the distribution of the marks. And for specific definition, you have to learn next, state the condition for this reaction. In what condition substitution reaction occur in alkanes? What are the conditions? Okay, here they ask only for condition. So it is ultraviolet light, UV. Write a chemical equation. So you can write like this, but chemical equation, write a molecular formula. So C2H6 plus Cl2, 1 chlorine will replace hydrogen, result in a formation of C2H5 Cl plus HCl. Compound R undergo addition reaction with bromine. So this addition reaction means when you have only one product, we call addition reaction. So what happened? A compound R undergo addition. So in reactions of alkene, the double bond will break. So this was CH2, double bond CH, double bond, a single bond CH3. And it is also called unsaturated hydrocarbon. It reacts with bromine. HCl will be there in the previous example because chlorine is group 7 and hydrogen plus 1. So it is HCl. So CH2, CH3 plus Br2. So what happened? The double bond will break. As the double bond will break, one bromine added to the first carbon and the second bromine added to a second carbon. And the final product does not have a double bond. It will turn into a single bond. So it will be CH2, Br is there, and then CH, Br, and then CH3. In the question, they say show all the bonds of the product. So we have to draw the structure of this compound and show all the atoms and all the bonds. So we have to represent only all the bonds as well. Like as we know, CH2 was there, the first one, then bromine is added to first carbon, and then the second one was CH, bromine is added to second carbon, and then it was CH3. Because we have to show all the atoms and all the bonds within the structure. Draw the structure of unbranched isomer of compound S, show all the atoms and all the bonds, and name the unbranched. We don't have to make a branch for S. Can you name S? What is this S? Hydrocarbon S. What's the name of this compound? 4 carbon atoms are there. So it is butene or butanene. So best way to draw the isomer of alkene, what we can do, there are two ways to draw the isomers. We can change the position of a double bond or draw a cyclic alkane. So just draw butene, or you can also, it's up to you, or you can draw a cyclic butane. So if I draw, and we have to show all the atoms and all the bonds. So 4 carbon atoms, the second and third, they will have, this will have 3 hydrogen, this will have 1 hydrogen, this will have 3 hydrogen. And what is the name of this compound? It is butene. Your cyclic, I will draw 4 carbon atoms first in a closed loop. And 2 are already form a bond, so 2 hydrogen will be there. 2 already form a bond, 2 hydrogen, 2 hydrogen, and 2 hydrogen. And then it will be cyclobutane. If I draw this one, it will be cyclobutane. Compound Q undergo polymerization. Name the polymer formed. What is compound Q? What is the name of this compound Q? It is ethene. So if it is ethene, what is a polymer formed by ethene? So whenever you draw a polymer, you don't have to draw a polymer, you just have to name the polymer. So because they undergo addition polymerization, so the result will be polyethene. Complete the chemical equation to show polymerization of compound Q. So how to represent? First, your monomer, this is called a monomer, should appear like letter H. Whenever you want to draw a polymer, first rearrange. There are blank pages, so you can use those. First rearrange this structure of the monomer. So your monomer should appear like letter H. So there is C double bonded with C. It should always appear like this. So 2 hydrogen with the first one, so 1 up, 1 down. 2 hydrogen with the second one, 1 up, 1 down. This is a monomer. But when I draw a polymer, so monomer is already drawn. I don't have to draw a monomer again. I just have to draw a polymer or complete the equation. I can put a bracket and then write N. So there will be N molecules will join together and form a long chain compound. Is it clear? The addition polymer formed by propene, formed by ethene, so that will be polyethene. In the next question, amino acids undergo polymerization to form a protein. Amino acid basically is a combination of amine and acid. So one side they have amine group, one side they have acid group. Draw a linkage in the diagram to show all the atoms and all the bonds. So one side amine group, and we have to complete this structure of a protein. So one side, if amine group is there, yeah, amide or peptide linkage. So, but because it's amino, it's the monomer was amino acid. So one side amine group is there, another side carboxylic group will be there. Same thing on the left hand side of this, the second molecule, one side amine group will be there. But I did not draw OH here because what happened? The carbon and nitrogen will link with each other and it will form amide or peptide linkage. So same way C double bonded with O, and then amine group is there, and amine group with carboxylic, it will form amide or peptide linkage, result in a formation of protein. In the next question, the structure shows an ester. Write the word equation for reaction which could use to make this ester. First thing, you should know the name of the ester so that you can identify how it is formed. Now, for ester, one side is a branch, another one is, so the part which is attached directly with oxygen, the carbon chain, that's a branch. The other one, which is C double bonded with O, that is the main chain. How many carbon atoms are there in the branch? So 2 carbon atoms, so it will be ethyl. And 4 carbon we include this as well. 1, 2, 3, 4. So 4 carbon atoms are there, so it will be butanoate. So it will be ethyl butanoate. And if it is ethyl butanoate, the first name is always coming from alcohol. And the second name of ester is coming from acid, carboxylic acid. So alcohol plus carboxylic acid give ester plus water, but we need the name of these alcohol, and so which alcohol will be there, because of we want ethyl, so this will be ethanol. Plus butanoic acid. gives ethyl butanoate plus water. Is it clear? This was the last question.